Hello to everybody. It's Thursday, and when I'm writing, you are writing, and I suggest that you do today's work with a pencil because we're going to be drawing things, and if you make a mistake, you want to be able to erase it. So you can see I'm using a pencil. Let's do this. It's December the 14th, 2017. Today we are going to talk about quadrilaterals. We're going to be drawing some of them and naming them. We are also going to do congruency. When we get to congruency, I'll explain it to you. It's the easiest thing ever. Okay, so quadrilaterals. Quadrilaterals are shapes that have 4 sides and 4 angles. Comes from qua, which means 4. So it has 4 sides and 4 angles. Okay, 4 sides and 4 angles. All right. The easiest one that we're going to start off with is a square. So a square has all its sides equal. And to show that the sides are equal, I'm going to put a line through all of them. This is equal to that, is equal to that, is equal to that. So if this is 2 centimeters, then this is 2, this is 2, that is 2. So all the sides are equal. And all the angles, all the corners are 90 degrees. Now, let's look at this for a minute. What is 90 plus 90 plus 90 plus 90? Well, 4 times 90 equals 360 degrees, which brings me to my next fact. All quadrilaterals, angles when you add it up, adds up to 360 degrees. Let's look at a rectangle. Short side, long side, long side. This long side is as long as that one. That's why I made 2 lines through those. The ones on the side are not the same, so I'm just going to make 1 line through them. So it seems like opposite sides are equal, and guess what? 90, 90, 90, 90. The total is 360 degrees. All right, so this is a square. This is a rectangle. Now, someone smart came along and took a square and did this. He pushed it over to the side like this. Watch this. Sorry, guys. Did this. Whoops. 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 Okay? All the sides are still the same length, but now the angles have changed. Opposite angles are equal, so this one is equal to that one. This one is equal to that one. So what do we see now? The angles as opposite angles are equal, but not all the angles are the same anymore. But guess what? Guess what? When you add up the angles, it still comes to 360 degrees. Now, what do we call this little shape? The square that became a pushed over square is called a rhombus. A rhombus. There we go, a rhombus. All right. A rectangle, same thing. When I push it over, has basically the same qualities. Now, not all 4 of the sides are equal like it is over here. The opposite sides are still equal, and opposite angles are equal. So what changed basically? It does not add up to 300, it does add up to 360 degrees. This little guy is called a parallelogram. Which brings me to the next word. What does parallel mean? Parallel means the following. It is opposite sides that will never ever touch, because they are always the same distance apart. Okay, let's see how it works here. Does this and these two sides are opposite each other, right? Are they ever going to touch? No. These two sides are keeping them apart. So I'm going to show you how to show parallelity. This line is parallel to that line. Is this line parallel to that line? Of course it is. This line is parallel to that line. You see those little arrows? The same with the parallelogram, the same with a rectangle, the same with a square, okay? So knowing when things are parallel is really important. Okay, it's like railroad tracks. The railroad tracks will always be the same distance apart, because if it's not, the train will derail, okay? Let's do some more quadrilaterals. Now the following quadrilateral has one set of parallel lines. This side is parallel to that side. However, if I connect the sides, then this side is not parallel to that side, because what happens is, if I take this side and I extend it like this, and I take this side and I extend it like this, what happens? It crosses at the top, and parallel lines can never cross. They must always be the same distance apart. So, what do we call this baby? This baby is called a trapezoid. But guess what? When you add up all the angles, when you add them up, it still comes to 360 degrees. Now I'm going to quickly show you another quadrilateral that we don't use much. It has two short sides that peak at the top and two longer sides coming down to the bottom. This side is as long as that side. This side is as long as that side. It's called a kite. A kite. And it looks like a kite, right? The thing that you need to know about this is it's a quadrilateral. It has no parallel lines, but when I add up all the angles, it still comes to 360 degrees. Okay? So let's quickly go over everything. You've got a trapezoid. It has one set of parallel lines. You've got a kite, no parallel lines. Both of these equals 360 degrees. You also have a square, 360 degrees. All the sides are even, all the angles are even. A rhombus, which is a square pushed to the side. Opposite sides are, all the sides are equal, and all the angles together is 360, and you've got a rectangle. Opposite sides are equal, they're parallel, all the angles are 90 degrees, it's 360, and a parallelogram is a rectangle. The only difference is the opposite angles are even, but it still equals to 360. All right. Got a little bit of a cough this morning. I'm going to turn the page back to where I was. Okay. There's one thing that I would like to show you, and it is this. Let's say I have a trapezoid, and let's say I have a duplicate of that trapezoid. This side is as long as that side. 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 So can you see what I'm doing? I'm putting the lines through as they compare to each other. This thing, this trapezoid, is exactly like this trapezoid. Now I'm going to show you the mathematical way to show that they are exactly the same. It's a line that looks like a lazy S that's sleeping on its side with an equal sign underneath it. And this sign means congruent. Congruent. Everything about it is the same. Now, here's a question. Can I take this one and turn it upside down? Sure I can. It's still congruent no matter how I turn it. I can turn it at an angle, I can turn it all the way around, but the fact is that they are still congruent. Then another word that I want to teach you is the word corresponding. So watch this. This top side corresponds to this top side. So if this was A, B, C, and D, and this was E, F, G, and H, I could say the following. Line A, B is congruent to line, pick up AB, put it down over there, E, F. Line E, F. Are you with me? Yeah. Angle A will be congruent to, pick it up, place it down, angle E. Can you see how this congruency works? Okay, so the one looks exactly like the other one, and they have corresponding sides and corresponding angles, and that in a nutshell is congruency and correspondence. Let's just write down that word, corresponding. It's the things that match. It's the things that match, the angles that match and the sides that match. Okay, we're now going to do some classwork, naming the quadrilaterals and working out how much angles are, now that we know that all quadrilaterals equal to 360 degrees. That's it for today, guys. Talk to you soon. Bye.